Let's look at our part 2 notes for circles. You'll see that this is actually incredibly short, just these two pictures right here. Tangent lines, we said before, are lines that touch at exactly one point. One thing that's cool though is whenever you draw a radius and you run it into a tangent line, you will always form a right angle every single time. So radius and tangent line make 90-degree angle. Radius and tangent lines make a 90-degree angle. And that's always going to be true, and we're going to use that property quite a bit. Because of the fact that that makes a 90-degree angle, a lot of times you end up with right triangles, such as this one here. So if you draw another line out of the circle here, you will end up with a right triangle. So you'll run into a lot of problems where you see these triangles that show up. They are right triangles if it's a radius and a tangent line coming together. And you can use Pythagorean theorem then to solve for any missing sides. This other image over here, we see a polygon, in this case it's a four-sided shape, a quadrilateral, drawn along the outside of a circle. It is circumscribed around the circle. All of these lines are tangent because they touch at exactly one point on the circle. So it's 4 lines that are tangent to the circle. We can actually figure out the perimeter because of using congruent triangles. So I'm going to real quick show you this, and then in the practice problems we'll work on specific examples. If I were to just pick this side here and this side here, I can prove that those two sides are exactly the same length, starting at D going to C, starting at B going to C. And the way I'm going to do that is if I draw myself a radius from Q to B, and I draw myself another radius from Q to D, I know that because these are tangent lines, I have right angles. I also know that since these are both radii of the same circle, that this and this are the same. So I have an angle and a side already. I can just get myself one more piece of information. If I were to draw from Q to C, kind of make up my own line here, I know that this side is going to be equal to itself because of reflexive. So if I look at this shape now, I have angle, side, side, and we know that angle, side, side is not a form of congruence, but when it's a right angle, I have hypotenuse, that's the green one, and a leg, the red one, and a right angle. So I, by HL, know that this triangle right here is congruent to this triangle right here. And if that's true, then by CPCTC, I know that all of the corresponding parts that match up between those two triangles are congruent, including these orange sides that I drew earlier, BC and DC. And I could repeat this process for every single one of these so that I would know that FE and ED are equal. I know that FG and GH are equal. I know that HA and AB are equal. And because of that, I can use that to help me figure out the perimeter in different problems.